Okay, in the previous page, I will provide you with an example by increasing this linear hash table by increasing this n number from 3 to 4, right? We mentioned that only one entry need to be changed. Change its position from the second bucket to the newly created fourth bucket. Besides extending like this, during the runtime, sometimes we may need to further increase or extend this linear hash table. If we increase n from 4 to 5, in other words, we have to indicate 5 different buckets. If we only use 2 bits in the hash function, it cannot project the keys to 5 different buckets, right? In other words, if we do the extension like this, we have to increase I as well by increasing I from 2 to 3. If we do so, then for all the key inputs, we have to check all the last 3 bits in defining this hash function. In other words, this hash function should be redefined. We will check all the last 3 bits 000, 001, 010, 011, as well as 100, 101, and etc. Right? All the hash function entries will be adjusted accordingly by checking the last 3 bits. At the same time, we also need to change the data or the pairs we have in the buckets right now. If we extend this n from 4 to 5, we check the last 3 bits. In other words, all the entries need to put into a new bucket accordingly. Now this one will be put in one bucket corresponding to 100 as the last 3 bits. This one will also be in the bucket for 100, right, as a new bucket. This one will be in the bucket for 010. This one will be in the 111, right, for the buckets. In other words, if we extend this n from 4 to 5, we have to adjust this I as well. If this I is adjusted, we have to change both hash function as well as the corresponding buckets accordingly. However, the storage space we extreme increase is still from 4 to 5, right? We will only have 5 buckets. And the extension mainly happens by moving the data among the buckets. Okay, so this is about extension of the linear hash table in a vertical way, right? So it can provide us with some flexibility to increase or to grow the hash table in both the horizontal way and the vertical way with these linear hash tables. And we also ensure each time if we increase this hash table, we will only choose one new bucket. It will not double the size as the extended hash table introduced before, right? So the increasing by one size is very good. It will not increase the storage space dramatically. Okay, so far we have introduced different data structures we can use for maintaining an index table. If you still remember, in the very beginning, we provide you with different index tables we can have in the real world. And then we introduce a very important data structure, it's called B plus tree. We mentioned some shortcomings with B plus tree, and we introduce a B tree. We also identify some problems with B tree and B plus tree. We mentioned if we want to search for some of the keys, we have to traverse from root to the different nodes. It will be time consuming if the tree is very deep. Therefore, we introduce the hash tables. In the very beginning, we introduce the conventional hash table. We mentioned we can grow the hash table in a horizontal way by creating some overflow blocks. However, if we grow too many overflow blocks, it will reduce the hash table to the linear list. It's very bad. Therefore, we introduce this extensive hash table, which can grow the hash tables in a vertical way by using the I bits in defining hash function in the buckets. We also mentioned that this extensive hash table we discussed before also has a shortcoming because each time we have to double its size if we plan to grow the hash table. Then we introduce this linear hash table in this part. We can grow the hash table in both horizontal way by introducing some overflow blocks, and we can also grow it in the vertical way by increasing the number. Each time, no matter which dimension we grow the hash table, the linear hash table, we will introduce only one single new block or new bucket. Okay, so far we have been discussing about these index tables. I hope you can follow me right for the materials we have covered, especially on the hash table this part. I hope you can go over all the materials carefully, and I hope you can understand these materials and digest this knowledge. And many of these materials we cover will appear in homework and whether in the final exams. Okay, so that's it for the indexing section. Thanks for your attention, and I hope you have a nice weekend.